Hi everyone, and thanks for tuning in to our video on linear programming. If you look at the title of our notes here, we're calling this linear programming. And what linear programming actually is it's the application of systems of linear inequalities. So we've been studying how to graph a system of linear inequalities and kind of find that feasible region, which is the final answer. Today we're actually going to apply that to a real life situation. So here is the situation. Now what I want you to do is read along with me as I read aloud, and if you have a highlighter, it might be good to highlight some things as I highlight them. Okay, so let's start here. Miss Callahan hires 2 kids from the neighborhood to do some work for her around the yard at her house. John mows the lawn and Ben rakes the leaves. Okay. John charges $3 per hour to mow the lawn. So I'm thinking $3 per hour is probably important information. So that's John's rate. John charges $3 for each hour he mows the lawn. And then Ben charges, he's a little cheaper, Ben charges $2.50 an hour to rake my leaves. Okay. It goes on to say, let X represent the number of hours John mows the lawn every year. Okay, so X goes with John's hours. I'm going to highlight that. X represents the hours that John mows. And then it says, let Y represent the number of hours Ben rakes. So that's important. Okay. Now let's get on to step 1. So step 1 says, write an equation that shows the amount of money, M, Ms. Callahan pays the boys each year. So money, that's telling me I have got to do something with the $2.50 and the $3. So my thought is I'm going to set my money, M, equal to, okay, let's start with the $3. So John charges $3 per hour, and X is the number of hours for John. So I think the amount of money that I need to pay John would be $3 an hour times X, the number of hours that he mows the lawn. So if he ends up mowing the lawn, let's say 20 hours per year, let's say in the summertime, you know, he comes 20 different times in the summer and mows for me, 20 times 3, I'd pay him $60 in the end. So I'm going to take the number of hours John works and multiply it by his price per hour. Remember, per means multiply. Just going to write that off to the side. Okay, per means multiply. Okay, now I'm also going to have to add to this what I pay Ben. So I pay Ben $2.50 an hour times the number of hours that he works, which is represented by Y. So I'll put $2.50 per hour times Y. That's my money equation. So that wasn't too terribly difficult. That's how much money I'm going to have to budget to pay these guys for the work that they do at my house. Okay, let's move on. Next it says, Ms. Callahan has made a few observations over the years, and there are 3 observations. So let's read these and possibly highlight as well. John and Ben spend a total of at least 40 hours a year working at Ms. Callahan's house. I'm going to highlight total of 40 hours a year. So together, the 2 of them work at least 40 hours a year. Next, John and Ben spend a total of no more than 90 hours a year working at my house. So that's important. Total is no more than 90. And finally, the number of hours Ben works a year is at least twice the number of hours John works a year. Boy, I think that whole sentence is important. The number of hours Ben works is at least twice the number of hours that John works. So I think Ben spends more time raking the leaves than John does mowing the lawn. Okay, step 2 says, write these observations, 1, 2, 3, as inequalities. Okay, we've been studying systems of inequalities. So there are going to be 3 inequalities in the system that we write. So it seems to be working with what we've been studying. So let's start with bullet number 1. Together, the 2 boys spend a total of at least 40 hours a year working. So we know X is the number of hours that John works, added to Y, the number of hours that Ben works. This has to be together a total, there's my total hours, at least 40. Now, don't make the common mistake of seeing the words at least and putting a less than symbol. At least actually means greater than or equal to 40 hours. If I tell you, hey, I need at least $40 to go to the mall, I want 40 or more. I want at least 40, because nothing in this world is cheap. So at least means greater than or equal to 40. Next, John and Ben.
Interruption. Nolan Kachi, please come to the main office. Nolan Kachi to the main office. Thank you.
Sorry about that. John and Ben spend a total of no more than 90 hours a year. So now, second inequality, X plus Y, no more than. That means less than or equal to 90. And finally, the number of hours Ben works. Okay, well, Ben's hours are Y. So the number of hours Ben works, here we are with at least again. At least means greater than or equal to. Twice, 2, twice the number of hours John works, and John is X. So there's my third inequality. The number of hours for Ben is at least twice the number of hours for John. Awesome. Okay, let's flip this over. Step 3 says, graph the inequalities from step 2. This is what we've been studying. Now it comes to fruition here. Okay, so if we're going to graph these, let me write these over here so we don't have to keep turning the page over. So the first one we have to graph is X plus Y is greater than or equal to 40. The second one we have to graph is X plus Y is less than or equal to 90. And then the final one we have to graph is Y is greater than or equal to 2X. So we kind of have 3 different inequalities in the system that we're going to graph. Okay, so let's get them graphable. So you can see the first 2 are in standard form. So we need to switch these over to slope-intercept. So we are going to start by moving some furniture around. So we're going to subtract X from both sides here. Here the X's will cancel and give me Y greater than or equal to negative X plus 40. Done. And I'm going to, where are those colored pencils I was using yesterday? Here we go. I'll make this one purple. Okay, second inequality. Let's do the same thing. Subtract X. Both sides. Cancel those. Y less than or equal to negative X plus 90. And we'll make him blue. This will be blue. And last but not least, guess what? This guy's already ready to roll. Oh, I don't want to make him blue though. Let me make him a different color. Let me make him green. This will be green. Miss Blanchard, can you I think Brooklyn's waiting. Can you just tell her to be, yeah, she can come in. She just has to be quiet. Sorry guys, we just have a little interruption. Okay, so there are our 3 inequalities. Okay, so what I need you to do, and you can pause the video by the way to do this. I already set it up. What I need you to do is kind of darken in the x-axis here, darken in the y-axis, and then like for the x-axis, we know that x represents the number of hours that John mows the lawn, so you can write that on the x-axis. And we know that Y represents the number of hours that Ben rakes the leaves. You can write that up the Y-axis. And then in order to get as high as 90 and 40, which are these Y-intercepts, our B values, I just went up and across by 5s. If you go 5, 10, 15, 20, you will get up to 90. And same thing on the x-axis. So why don't you pause the video now and catch up with me, and then when you hit play again, we'll start graphing. Okay, here we go. So we're going to graph our first inequality. Our B value in this first inequality is 40. So I'm going to come up the y-axis, 40, put my dot, and then my slope, my m, is -1. So I'm just going to come down 1, right 1, down 1, right 1. Now you might be thinking, Miss Callahan, you're really coming down 5, right 5, because each block represents 5. But if you think about it, I'll come up here. If you come down 5, right 5, isn't that the same as -1? So we're okay. Down 1, right 1, down 1, right 1. And you're just going to keep doing that until you can't go no more. Okay. And you should actually land on 40 on the x-axis as well. So you're at 40 on the y and you end up at 40 on the x. Now we're going to draw a solid line because it's greater than or equal to. So we will include the points in our solution on the line. And now we got to think about our shading. Look at your symbol, greater than or equal to. So put your pencil on the y-intercept with regard to the y-axis. Greater would be up the y-axis. So when you're thinking about the line, greater than is this way, less would be this way. So we are definitely going up. So I'm going to lightly color in purple this side of the line. Can you see that? Real light in there. Okay, now let's move to blue. The blue line, we are going to start at our B value of 90. So up we go to the tippy top to 90, and our slope, M, is -1 again. So we're going to come down 5, right 5, which is the same as -1, all the way down. So keep it going. Eventually, if you do it correctly, you're going to end up at 90 on the x-axis as well. And indeed I do. I'm going to make it a solid line because it's less than or equal to. And I am going to shade less than or equal to the line. So put your pencil on the y-intercept. Y less than would be going down the y-axis. So with regard to the line, we don't want to go greater, we want to go less. So that puts me down here. So if I was stopping this right now and shading my feasible region, it would be right here in the middle of these two lines. This is where right now the purple meets the blue. This is out,